Hello, hi. Now I want to summarize about intermediate value theorem, IVT, and graphical method. So IVT is to show that there is a root or at least a root for fx equals to 0 in the interval a, b. Okay, first we compute fa and fb, then we make a reason and conclusion. Since f is continuous in AB with fa dot fb less than 0, there is a root or at least a root for fx equals to 0 in the interval AB. Okay, look at for example 1. Show that the equation ln x equals to x squared minus 3 has a root or at least a root in the interval 1, 2. So we rearrange the equation and let fx equals to ln x minus x squared plus 3. So we substitute 1 into this equation. Then we get 2 greater than 0. Okay, then we substitute 2, then we get negative 0.3069 that less than 0. So we make a reason and conclusion. Since f is continuous in 1, 2 with f1 dot f2 less than 0, there is a root or at least a root for ln x minus x squared plus 3 equals to 0 in the interval 1, 2. Okay, look at example 2. The equation x cubed minus 3x plus 1 equals 0 has 3 real roots. Show that one of the root lies between negative 2 and negative 1. So we use the IVT. Okay, first, okay, we let fx equals to x cubed minus 3x plus 1. So we substitute x equals to negative 2 into this equation and we get negative 1 that less than 0. Okay, when we substitute x equals to negative 1, we get 3 that greater than 0. Okay, you can make this conclusion like this, but you have to add fx is continuous in negative 2, negative 1. Okay, so f negative 2, f negative 3, this is not f negative 3, this is f negative 1 less than 0, and using intermediate value theorem, so the root lies between x equals to negative 2 and x equals to negative 1. Okay, now graphical method. Okay, to show that there is only one root for fx equals to 0 in the interval a, b. Okay, first we rearrange fx equals to 0 into gx equals to hx. Okay, where both g and h are sketchable and simple function in the interval a, b. Then we sketch the curve of the function, okay, g and h in the same coordinate axis. May sketch wider than the interval AB. So we indicate that there is only one intersection point between the curve in the interval AB. Then we make conclusion that there is only one root fx equals to 0 in the interval AB. Okay, note that if curves, okay, drawn without indicating clearly that the intersection point lies in the interval AB, then may add on with IVT to show that there is a root for fx equals to 0 in the interval AB. Okay, look at for this example. Okay, show that there is only one root for x power 5 plus x minus 8 equals to 0 in the interval 1, 2. Okay, so from this graph, we indicate, okay, the intersection points that lies in the interval 1, 2. Okay, and you must write 1, 2, 3, 4, 5, 6, 7, 8. So since there is only one intersection point between the curve in the interval 1, 2, so there is only one root for x power of 5 plus x minus 8 equals to 0 in the interval 1, 2. Okay, so now if your curve drawn without indicating clearly that the intersection point lies in the interval 1, 2, you just write 0 until 8. So you have to add on with the IVT. Okay, so we substitute 1 and 2 into the equation fx. Okay, then you make conclusion. Since f is continuous in 1, 2 with f1, f2 are opposite signs, or f1 the f2 less than 0, and curves show that there is only one intersection point in 0 to 8. Okay, why from 0 to 8? Because you state that 0 to 8. Okay, there is only one root for x power 5 plus x minus 8 equals to 0 in the interval 1, 2. Okay, for example 2, so we sketch the line y equals to 2x minus 1. Okay, 2x minus 1, and the curve y equals to sine x. Okay, for negative pi to pi. So we write the scale and we indicate clearly that there is one intersection point in the interval negative pi to pi. Okay, so since line and curve has only one intersection point, implies 2x minus 1 equals to sin x has only one real root for negative pi to pi. Okay, this is a common error. Okay, no scale. Okay, and okay, you just make a conclusion. They are one intersection point. Yes, but which interval? Okay, so you have to indicate clearly that intersection point lies in the interval what? Okay, interval A, B. Okay, so this one no mark. Okay, now show that equation 3 ln x equals to 6 minus x has only one real root. Okay, and it lies between x equals to 2 and x equals to 3, meaning that okay, if we have to show the equation has only one real root, so we use a graphical method. So we have to sketch the graph. Okay, then lies between x equals to 2 and x equals to 3, so we have to show with IVT. Okay, so this is the graph. Okay, then there is one intersection point. The equation has one real root, so there is not proper reason and conclusion. Okay, so you have to write, since there is only one intersection point in the interval 2, 3, so there is only one real root for x power 5 plus x minus 8 equals to 0 in the interval 2, 3. Okay, then use IVT to show that this equation lies, okay, between x equals to and x equals to 3. Okay, so we substitute 2 and 3 into the equation, then we get that f2 the f3 less than 0, but you have to state that fx is continuous in 2, 3. Okay, f2 f3 less than 0, and using IVT the root lies between x equals to 2 and x equals to 3. Okay, thank you.